Okay, so now some other ways of determining how many organisms you have. This way, one way you can use is just to count them. So they call it a direct microscopic method. So you would just be counting them. So the you use a specialized slide, and this slide is either called a Petroff-Hauser counting chamber, but most of the time we just call it most of the time we just call it a hemocytometer. So a hemocytometer, if you look at that word, so hemo is blood and cyto is cell and meter. So originally this was designed to count blood cells. We used to teach you how to do that in anatomy, but I don't think you do anymore. So it's just a specialized slide. It's calibrated and it has a grid on it, and you can count how many cells are in the grid, and then there are a calculation that you can do to figure out how many are in your original broth. So it's not hard, it's just a little tedious. The disadvantage is when you look at these, you can't determine whether they're alive or dead. So you might be counting dead cells too, and that's not really your goal. You want to try to figure out how many living cells you have. So you can't determine whether they're alive or dead from just looking at them. So hemocytometer. Okay, now most probable number is used usually when you're working with water. So if you're doing something with water quality, usually the number of organisms that are in the water is not super duper high. They're kind of dilute, but they could cause diarrhea. They could make you really sick. So one of the things that you do is you take the water, you take a sample of the water, and you try to grow the organism. So you put a little tube in here, and we'll actually use these little tubes. If something's growing in there, you get a little gas bubble. So something's growing there, something's growing there, there. If you look at this one, nothing's growing. And then there's a chart you can use to calculate it, and we'll have to look at the chart together. It can also be used when the bacteria won't grow on agar, so you wouldn't be able to do a streak plate. You'd have to use broth. So it's based on dilutions. It's pretty straightforward. I'll show you how to do it. So water, or when they won't grow on agar. So like if they're sampling greenbrier in the summer, this is one way that they could do it. Okay, so we already talked about this. We talked about doing serial dilutions, counting, spreading them on the plate, and then incubating them, and then counting and determining colony-forming units. So most of the time, what this is supposed to show you, most of the time, is one plate is not enough. You have to do replicates or triplicates. Okay, now, easy way to determine how many cells you have is to use a spectrophotometer, just like you use in biology or chemistry. And you measure the turbidity, or the optical density, the OD, of the liquid. So the cloudier it is, the more bacteria you have. The advantage, it's really, really easy. It's super duper fast. You know, it takes like a minute. But the disadvantage is you can't tell whether they're alive or dead. It's really, really easy though. We use it all the time. Okay, a calibrated loop. So the idea behind this, so this is used for urine testing, is they take like a single use loop that's calibrated, and you know how much is in there. So usually it's about 10 microliters is in each one of those loops. So you take the loop, you dip it in the urine, and then you spread it on a plate. And you can figure out how many organisms are growing in the urine. So it's really, really straightforward too. Generation time. So how fast do things grow? So 20 minutes is the shortest amount of time for bacteria to reproduce, and that's E. coli. If everything's going right for E. coli, 20 minutes. It's really, really fast. 20 hours or a day is typical. or 20 minutes to 20 hours. So it depends on what organism you're growing. Things, tuberculosis, leprosy, those mycobacteria, they grow slow. Now, one way to grow organisms, like if you need to grow a lot, we're growing things in broth. So we're just using a single test tube. And we're doing about 5 milliliters of broth. But a way to grow things more efficiently is to use this machine. They're either called bioreactors. So bio, like biology, and then a reactor. So it's just this little vessel. And what you control is the pH. You can control the dissolved oxygen. You can control the amount of media that's in there. So it's just a way to grow things really efficiently. Oops, you hear the cat? So there are all different things that can affect how microbes grow, and I have like a little laundry list here, and we're going to talk about each of those individually and just kind of hit on them.